How does a space shuttle pilot know exactly where to steer, even when flying upside down or at Mach 25, to land on a 300-foot wide runway from space? Stick around because the answer lies in one of the most overlooked but powerful instruments in the cockpit. In this issue of Spacecraft Guide, I am going to use my over 20,000 hours of flight time to teach you how to fly the space shuttle. And we're going to work on an instrument which is really cool. I kind of wish that I had this on my airplane, but it is used in the space shuttle to help it get into outer space and guide itself back to. So if you click on the primary flight display, it takes you to the primary flight display page, and we are going to come down here to this instrument, and we're going to look at this pointer right here, the Earth Relative Velocity Bearing Pointer. And when you click on it, it takes you to the Earth Relative Velocity Bearing Pointer page. Now we see here that this pointer right here with the big E on it displays the heading of the relative velocity, or Vrel, vector with respect to the target insertion orbit plane. So what we're talking about is we're trying to get into that plane to go into orbit or into outer space, and this is telling us the angular difference between the velocity relative, which is the relative velocity as referenced towards Earth, and the orbiter nose, and then beta is displayed in a digital readout in the upper left of the HSI. Both the E pointers, this one right here, and the beta box are pertinent when on the solid rocket boosters, the SRBs, and through the solid rocket booster separation. They will be removed blank after a mission elapsed time, MET, of 2 minutes and 30 seconds or an altitude of 200,000 feet. So this is actually telling your Earth relative velocity. So as you can see, our velocity is taking us a little bit off course here to this side. You can see it's not on the lubber line. And to get this back on course, we're having to follow this course arrow here, course error indicator, this right here. We're going to have to turn this way, and that's going to bring our velocity from on this side of the lubber line, or 0, to this side. And we're trying to move that velocity, the velocity vector basically, from going this way back over to here. And when we do, then that'll line up on 0, and that will mean we are right on target with respect to the target insertion orbit plane. Now, if you are a subscriber to my Patreon page, either paying or free, and free means you don't pay anything. So what are you waiting for? If you are a free or paying subscriber and you click on schematic, for the 55th anniversary of Apollo 13, I have this special gift for my subscribers. It's the first chapter of my book, How to Fly the Space Shuttle. You can also email me to get a preview of the next chapter. Don't forget to subscribe to be notified when the next chapter drops, and look below to find the link to get the free book.